guys, thank you for clicking on that link. This is Module 11, Introduction to Drain, Waste, and Vent. We know that as DWV systems. The objectives: upon completion of this module, you will be able to do the following: explain how waste moves from fixture through the drain system to the environment, identify the major components of a drainage system and describe their functions, identify the different types of traps and their components, explain the importance of traps and identify the ways that traps lose their seals, identify significant code and health issues, violations, and consequences related to the DWV systems. Your performance task will be sketch an isometric drawing of a simple DWV system and label its components. Start with this introduction. As a plumber, you need to understand how drainage systems works. This module describes the flow of waste products from a building to the treatment facilities and back to the ecosystem. That's just the streams, the rivers, and the lakes. The cycle begins at the fixture drains that connect to the drain, waste, and vent piping system. So that kind of starts me off on a note right there. Waste enters the DWV system from fixture drains. Go ahead and write that down. This next one is just simply stating that there are two major identifications in drainage systems, and that's going to be storm and building. Go ahead and write that down. The next note here, we're talking about gray water systems. This is piping collects used water from sinks, showers, and laundry facilities. You notice toilets are not in here. That is not considered gray water. That is black water. Gray water is mainly used to flush toilets and provide irrigation for landscapes. So if you collected this water from sinks, showers, and laundry facilities, you could essentially recycle it through catch basins and pump it back into your, say, toilet tank to flush the toilet. And we're okay with that. Most jurisdictions, however, this is a note, most jurisdictions do not allow gray water irrigation of edible plants. Okay, so make sure you write that down. Guys, we've talked about traps before. We know about this. A trap is a fitting or device that provides a liquid seal of 2 to 4 inches. Remember, I know I've said this before in these classes. The reason the trap is there, we can't smell through water, so they invented the trap, and that provides a liquid seal. That liquid seal we can't smell to the other side. Alright, next one, guys. I know I talked about this in some of my intro classes. The water closet or toilet, as most know it, has integral traps. That means they are designed to already have a trap in them. It is against code. It is a code violation to have 2 traps on one fixture. So that creates a siphonage. It'll pull that water out of both of them, and we can't have that. Just note that water closets have a trap already installed. Alright, I just spoke about siphonage. Siphonage can happen when you have 2 traps back to back, or if you have an S trap, which is also against all codes. But if this trap arm is over a 1/4 inch per foot fall, you could also have a siphonage here. So what happens is this water drains down into the trap. The pressure here is greater than the pressure here. So what happens is all this weight pushes this water up and out. The idea is here, you want it to push it up and out, and then this water stay in place, because this is your trap seal. Any sewage smell is over here. The vent, the pressure is different here, so the vent is bringing air in this way behind the positive pressure of the water. But if this gets too high, it will go out too quickly, and therefore just siphon that water right out of there. So make sure you note that over a 1/4 inch per foot fall can cause siphonage. Alright, here's that positive pressure I was talking about. So the weight is creating a positive pressure this way, and the negative pressure is here. So the vent is drawing in air because of this negative pressure. Evaporation. Alright, that's pretty self-explanatory, but just go ahead and note this. This is most likely to happen in traps that are seldom used. Makes sense, right? You don't use the trap, it dries up. You smell what's on the other side. So use the trap. Next thing, we're talking about general DWV fittings. You should note it. Waste should flow from the bale to the spigot. The bail would be the female, and the spigot is the male. The next note is to determine what your degrees of bend is. This is called a quarter bend. You probably already know we call this a 90, but how you figure that out is it's 1/4, that is a quarter, so 1/4 by 360 equals 1/4 times 360 equals 90 degrees. All right, there's going to be a test question on there, and it's not going to be exactly that, but let me go ahead and give you a review or a question you can work on right now. All right, so what if I said what is 1/8 in degrees? Well, how you plug that in is 1/8 times 360. What do you come up with? All right, if you came up with 45, you're right. All right, so just practice that on these other fittings and tell me what, just study that, okay? Good job. All right, we're talking about sanitary fittings. Yeah, they are available in single and double patterns. That means this sanitary fitting is just going one way. All right, this one is accepting directions from two ways. Here's these combination fittings. I know we talked about them before, but they are kind of a note, a simple idea of a combination fitting. They also reduce the number of fittings needed. You know that because we've talked about it. All right, here we go. You got these architects and engineers. They design the piping system, determine the grade. But unfortunately, they don't always get it right. So the note is the plumber selects the grade according to applicable code. Did I get that word right? Applicable? Applicable? There we go. Applicable? Got it. Write it down. So there's two notes here. Let me start with this first one. Manholes must be provided for underground piping that is 8 inches or larger in diameter. Write that down. Now, the next note here, the final note, is leaving the building, residential building, commercial building, you have to have a clean out within 5 feet. All right, and then once the sewer gets out into the city sewer, the building sewer gets out into the city drainage system, the city sewer, there's got to be manholes for the intervals cannot be more than 400 feet apart. Three different rules of thumb here: not more than 400 feet apart. 400 feet apart at every major change of direction. And I always like to put this in here because you can separate major change of direction in just one change of direction or a combination. If I've got my building coming into the sanitary sewer right here, I've got to have a manhole around here somewhere because I've got a change of direction and a combination, okay? So I'm going to have what is deemed as a manhole, also I can be used as a clean out, and I've got a clean out coming outside of my building, all right? Just note that there's going to be a question that's wanting to trip you up, and it's talking about the differences or where a couple of clean outs is needed versus the rest of them being just one. So all of them probably need some sort of form of clean out, but there's one that is very specific in needing 2 clean outs. So just know what it's asking and know how to look for those in words. Okay, so you have a building and you have a combination. City sewer, clean out at the building, you're going to have two kind of clean outs there. Okay, I don't care how far apart you are from it, it's just building's got to have a clean out, you got a combination of the street, you're going to have a manhole which can be used as a clean out.
Note this is under health issues after the end of this module, and it's in the past diseases such as cholera have been traced to failures of DWV systems, so make sure you write that down.
Alright guys, and that'll do that for Module 11. Make sure you got your notes and get prepared for the exam, and thank you so much. Have a good one. Later.